Yep, hello everyone, and welcome to my second session during this series about cloud and about Azure for the test engineers. My name again is Anton Boyko. I'm a Microsoft Azure MVP. I'm also Microsoft Regional Director, and here on this slide you can see my email. If you will have any questions that will remain unanswered at the end of this session, or maybe you want to talk about the IT or cloud in general, feel free to drop me an email to that address. I respond, at least I try to respond to all the emails. Sometimes it may take a bit more time because I may be overwhelmed with my other activities, but yeah, usually it happens no longer than in a week. And before we will actually proceed with the main topic of our event today. So what I would like to share with you upfront, I would like to share this QR code and this information that actually this series is sponsored by Microsoft, and we will be talking about Azure Cloud today. So feel free to check these links, feel free to check those that QR code, and it will basically guide you to the Microsoft Azure website with all the documentation that is needed for you to start working with Azure Cloud. And today I will show you a few demos if you will be really interested to dive in deeper into those technologies. Again, feel free to check those links. There are a lot of documentation about all the things that I will show to you today. On that, let's actually go back to the content of our presentation. And today, as I promised during my last session, so today we will have a series of demos. So technically, no slides, no theoretical information will be presented here today. I will try to focus all the attention on demos only. And the first demo will be about the service that we briefly talked about during the previous session, which called Azure DevTest Labs. And we will talk about such components in particular as artifacts, formulas, environments, and secrets of that particular service. So let me exit the presentation mode and let me open let me open this guy here. Yep, so I have millions of tabs open. So what do we have here? I'm on the Azure portal and I've already created my first instance of Azure DevTest Lab. So the process of creating that instance is pretty much simple and straightforward and quite boring actually. You just create a service, give it a name, and that's basically it. So let's actually try to check what we have within that service. So what are the components of this service are? So first of all, I have my virtual machines. So here under my virtual machines, what I can do, I can create a virtual machine for me. So why it may be needed? It may be needed because I may want to test some application, how it works on a particular operation system, or I may want to test, I don't know, like something from a specific browser and so on and so forth. And I want to have an isolated test environment. So I can create easily a virtual machine here, and that virtual machine, again, as I was saying, I can either use it as a test host, or I can even deploy my application to it and test my application on that environment. So let's actually do that. Let me hit add. So first thing that we need to do, we need to choose a base image, and it's loading, it's taking some time. And as you can see, there are extremely huge amount of all the different kinds of images here. So let's do, oops, sorry, need to switch to English. So let's search for something like Windows 10, for example. And as you can see, even for Windows 10, there are a lot of images here. So you can do the, let's say, vanilla Windows 10 enterprise image if you will choose this one, or you can say that, okay, guys, I want on top of my Windows 10 also to have a Visual Studio Enterprise Edition, Community Edition, and so on and so forth. Additionally, what you can also do, you can put your own images here if needed, but those images that you're seeing right now on your screen, as you can see, they were published by Microsoft, and Microsoft kind of guarantees you that there will be no malware, no spyware, basically no applications that are not needed on your test environment there. So that will be only those components that vendor decided to put on those machines. Let's start with Windows 10 Enterprise as a very, very vanilla image. So what we need to do here, we need to provide a virtual machine name. And by default, as you can see, it was populated by me001. That's actually fine with me, a pretty good name. Next, I need to provide a password and the username to basically connect to the RDP after that machine will be created. So let's use the username aboiko, and then password. Again, we can either type a password here, or we can say that I would like to use a saved password from the secret. And as you can see, I already have one password there, which I called password-12. So I will use this one. This is the name of the password, of course, not its value. Then what I need to do, I need to choose the size of my virtual machine. By default, it was basic A3, but as you can see, based on that message, the basic size is not allowed here. So let me change it to something different. Let's use D2V3, which is 2 CPU, 8 gigs of RAM, and so on and so forth. So this one is actually quite good. And this may look like as a very, very simplified version of, let's say, a regular UI that you may be familiar with already when you're creating virtual machines. But the big idea here and the big, let's say, benefit of using the Azure DevTest Lab comparing to the other services, like, for example, the regular virtual machine service, is the power of artifacts. So as you can see, currently under the artifacts, I have 0 artifacts configured. So let me click on this one, add or remove artifacts. And here, basically, I already have a predefined gallery, a predefined set of components that I will be able to use, basically, that I will be able to install on my machine on demand. So I can say, okay, you know, for this particular project, for this particular set of test scenarios and so on and so forth, I would like to use 7-zip on that machine. So this is the description of that artifact, publisher Microsoft, perfect. Okay, I will install it. What else I may want to have? Let's say that I want to install Atom as an editor. Here, as you can see, I need to provide some additional arguments to do that. For example, I need to specify the username and the password because on behalf of that user, that editor will be installed. So if I'm not mistaken, the user that we are creating is Anton Boyko. And again, we will pick the same password from here. Perfect. So what else? Okay, let's do Azure PowerShell. We may need it. Let's do Chrome, for example. Okay, what I can also do, I can clone a Git repo here. Of course, I need to provide some additional parameters, for example, like Git repo URI, the destination. So let me just do something like this, just because I want to show you how it works. I want just to pass the validation here. So let's say that that will be folder 01, and yeah, let's say that we configured everything. So provided the URI of our repo, we selected to which exact folder on the file system we want this repo to be cloned, and we also specified which exact branch we would like to clone, and also we provided a secret, basically a personal access token for this specific Git repo. And as you can see here, if I have that secret somewhere stored in my Azure DevTest Lab, I can actually pull it from an artifact. Okay, and after that, the reason why I was showing you that, after that, if I need the second repo, I can do that as well. So I can clone some second repo also here like this. So basically, same artifact, two different configurations, and both of them will be basically applied to this machine. Let's scroll a bit further and let's see what I have here. For example, if I will go here, I can see that there's a Selenium here and also Selenium Grid Hub and Selenium Grid Node, which is perfect. I can do Slack and so on and so forth. But hey, I do have a Visual Studio Code here. So I can actually select Visual Studio Code, and then actually, if I will have Visual Studio Code, I don't need to have Atom anymore. So I can basically delete Atom from here. And because, of course, we also provided some fake values here for this Git repo and for the next one as well, let's delete them as well. And additionally, as you can see, what I can do, I can actually also move those artifacts up and down. I can decide in which order they will be applied. And even if I need to, let's say, restart my machines to finish the installation of this or that particular component, there used to be a task for that here as well. For example, I can restart my virtual machine if needed. And again, as I was showing you with the Git repos, I can actually install, for example, one component, then I can restart and I can install a few more components, then I can restart it again if I need that. So here I'm basically configuring the set of artifacts and that's it. I can go to advanced settings, but on advanced settings, there are mostly settings that may be needed for the connectivity. So there are some settings related to how the virtual network or how the networking in general will work with this virtual machine. But there are a few other settings that also important to pay attention on this tab. So first of all, I can say that this virtual machine may be either claimable or not claimable. So what that actually means? It means that if for some case, for some scenario, I need to lock this machine only for myself, basically we may have like a shared machine, and then me as a QA engineer, I need to choose the virtual machine number 15, for example, and to execute some tests there. Then I can go and say, hey guys, I claim this machine for like, I don't know, like an hour, a day, a week, or something like that. But yeah, I mean, like if you're working as basically the only one person, or if you don't need to technically go to that virtual machine via the RDP session, and you will use it only as a host for some automation, like for example, Selenium or something similar, then actually you can skip that and make it non-claimable. Additionally, the thing here is that if I need more than one virtual machine, if, for example, I need 5 copies of this virtual machine, I can, oh, sorry, I probably clicked that by accident. So yeah, if I need to have 5 copies of virtual machine, that's also possible. I can do 5, I can do 55. That basically depends only on the size of my credit card limit. So if I have enough credits on my credit card, then I can do even more than that. But for our case here, for our demo today, let's just stick with one instance. And additionally, what I can say, I can put the expiration date here as well. If I know that, for example, I will be testing this release, this particular component for like a week, then I can say, okay, let's say at this day at midnight, I want this machine to be automatically removed. And then let's switch back to the basic settings. That's pretty much it. So now we can hit the create and create our virtual machine. While the virtual machine is created, let's investigate some other options that are also available here for Azure DevTest Lab, and why I will show you basically why I believe that this is such a cool service, especially for the QA engineers. So the next thing is my environments. Okay, so here we have only the virtual machines, here we have my environments. So what will be the difference? Technically, if you need to have, I don't know, like more than one machine to represent the entire environment, or for example, you may want to have a virtual machine as a dedicated host to run your testing scenarios. And in addition to that, you need to set up, for example, I don't know, a web app, a database, deploy your code there. So you will have an isolated environment that you can use to run your tests against it. Then you are in the right place, because if I will go to my environments again, I can click add and just give it a minute. And this is basically, for now, the gallery is, as you can see, not so rich as for the virtual machine images. But anyway, for example, this one here, web app with SQL database, it will represent actually not the one virtual machine, it will represent the whole bunch of resources, it will represent the whole environment. We need to provide some additional configurations here. So let's use for the environment name something like demo 2021 administrator login. Okay, let it be a boyco, and database password, let's use the same password here. So we can add, and in that way, basically, we are adding a new environment. We're adding an environment, and then, as I was saying, we will be able to use that environment to first deploy our application there, and after that, run our tests against that dedicated version of environment. Why this is important? It's important because, for example, there may be, I don't know, let's say the main branch or like the main release that the QA team is testing right now, but additionally, there may be a hotfix, and additionally, you may want to test the hotfix as well, but you don't want to mess them on the same environment. You don't want to run basically test scenarios for two different versions of code on the same environment, which is quite a good reason in general. So that is why you're creating a dedicated environment. You deploy your application there, you test your hotfix, and because, as I was saying, here in Azure, like in any other cloud in general, you're paying only for that amount of resources that you actually consumed. That basically means that if you'll provision the new environment for a short term, for like, I don't know, let's say a day, and then after you will test a hotfix and do the deploy, you will remove that environment, then you will pay only for 1 day. And usually, if we need to have that environment for 1 day, then usually the price of this environment is about like a few dollars, let's say $10 max. At least my experience shows that for the most cases, $10 per day can actually cover a pretty big environment, and that's suitable for like the majority of the projects that are there all over the internet. My data disks, we will skip that for now. Let's go to my secrets. So as you can see here, I have this password 12, and I can add a new secret. I can provide a name and also a value here. And I can basically save it as a new secret. In this way, I can save, as I was saying, either the passwords that I will be then reusing on all the different environments, on all the different virtual machines that I would create, or if I need to, for example, connect to some Git repos, what I can do, I can put the security tokens there, and so on and so forth. Okay. Okay, so the virtual machine will not be created for some reason. Probably, yeah, I don't have access to that particular repo. Okay, that's fine. Let's just create a second machine really fast, but we will use a different image. I will use a Windows Server image, something like 2019. So Windows Server 2019 data center. Okay. So I will use this password. I will use this username. I mean, like I just want to create at least one virtual machine and show to you how it works. And let me just add some artifacts here, for example, like 7-zip, Chrome, and also Visual Studio Code. That should be enough. Okay, create. Okay, let's try the second one. I do believe that it will work. So the reason actually why the first one was unable to create, that's probably on me, that's my mistake, because technically to be able to use Windows 10, like the client operational system, you need to basically apply for a specific license of Windows 10. Because this subscription that I'm using right now, this is, let's say, the free subscription that I'm using. So I do believe that on this particular free subscription, that license was not configured properly. So that is why the creation of this particular virtual machine failed. Yeah, but with Windows Server, that should not be the case. Anyway, we finished on my secrets, and while the virtual machine is created, let me go and show you what I have here under the configuration and policies for the whole DevTest Lab, for the whole instance of a DevTest Lab. So first of all, as an admin of this DevTest Lab, what I can do, I can configure the allowed virtual machine sizes. So for example, if I know that 2 CPUs and 8 gigs of RAM will be enough to test everything, then I can allow only the virtual machines of that specific size. Also, I can basically put a limit of virtual machines, amount of virtual machines for one user, or I can put the limit of virtual machines for the entire lab. Additionally, there are some lab settings here. So what is important is that I can basically configure some additional parameters, for example, like connection speed, the gateway hostname, the gateway token secret, and so on and so forth. But what is, oh, actually, this is actually the cool feature that I almost missed. So lab announcement. If you want to say something like provide some information to your QA team, to your engineers, you can enable the lab announcement, and that announcement will pop up for all the users as soon as they will log into Azure portal and as soon as they will open this particular instance of Azure DevTest Lab. But actually, I was moving to this area here. So if you remember on my previous session, we were talking about that here in Azure, one of the most classic scenarios and one of the easiest way how you can benefit from the cloud in general is to use the on-off scenario for your compute resources. So what that actually means here under the schedules, I can configure the auto schedule. For example, I can configure the auto shutdown for my virtual machines. As you can see, it's currently enabled and it's configured to my time zone, which is UTC +2, and it's configured for 11 p.m. So by configuring that, I am assuming that no one will stay after 11 p.m. at work. So that is why if someone, for example, by mistake or something like that, if someone by mistake forgets to shut down the virtual machine, I can do that automatically from here. And that will help me to save actually a lot of money. And additionally, for now that's disabled, but I can enable that as well. What I can do, I can also send a notification that, hey guys, I will shut down some virtual machines. I can either do that via email, or I can send that as a webhook, or I can do both. So let me put my email here. Yeah. So with this configuration, if I'm not mistaken, 30 minutes before the virtual machine will be about to turn off, I will get that email to my inbox that will say that, hey, soon we will shut down the virtual machine. If you want us to basically keep it up and running, please follow this URL and please like disable the auto shutdown. So let's save this configuration for now. Additionally, what I can do, I can configure the auto start for my machines. So let's switch it to yes, and let it be 7 a.m., basically same time zone, but here only during Monday, Tuesday, Wednesday, Thursday, and Friday. So, I mean, like, how awesome is that? If I will configure everything here correctly, if we will assume that we will have a working day that will be, I don't know, let's say 12 hours long. So for example, I will start my machine at 8 a.m. and I will shut down my machine at 8 p.m. So I have 12 hours during the day when the virtual machine will be working, and then I will run them only Monday to Friday, and for Saturday and Sunday I will keep them turned off. Then I will repeat again, that was the calculation from my previous session, but I still do believe that this is very important to highlight here explicitly again. It will cost me only the 30%, of the actual cost of the monthly basically fee for that virtual machine, comparing to what I would pay for that if I will need to pay 24/7. So that basically means that with the auto shutdown and auto start for my DevTest Lab, I will be able either to reduce my budget to only 30% for the infrastructure cost, or I will be able basically for the same amount of money to get 3 times more environments. So that basically means that for each and every QA person, if I need to provide a dedicated environment, that will be much cheaper with this auto scheduler configured here. Additionally, what I can do, let me go to this tab. Let's save it as well. So let me actually go to this tab first. So mandatory artifacts. If I want, what I can do again as a DevTest Lab admin, I can configure some mandatory artifacts to be installed on each and every machine. So what I can do, for example, I can add the Chrome browser and the Visual Studio Code. I don't know. Or maybe 7-zip also is a good idea to put as a mandatory artifact. And also Visual Studio Code. Okay, so now, and I save it. So now when any other person on the team, or even myself, when we will claim any, or not claim, when we will create a new virtual machine, those artifacts will be installed automatically. Let's go to repos here. So this is actually an interesting thing, because for the images, as I was showing you, for the images, you will be mostly using basically those default images like Windows Server or Ubuntu Server or something like that. But what if you will need to install some custom artifacts there? What if you need to test the desktop application or something similar, and you need that desktop application to be installed to that particular virtual machine so you can actually test it? Or for example, what if you need to run some specific tests in your Mozilla Firefox browser? There is no artifact for Mozilla Firefox, so how you can actually cover that? What are the options? How you can still automate that? And you will be able to do that with the power of connected repos here. As you can see, currently, there are only 2 public repos connected basically to this Azure DevTest Lab, and both of them, this is the repo for the artifacts and the repo for the environments, both of them are actually pointing to this particular repo on a GitHub. This is the official, as you can see, this is official Azure repo, which called Azure DevTest Lab. And here, please pay close attention to those 2 folders that I'm showing to you, the artifacts and the environments. So let's start with the environments. So here under the environments, you have this structure. So under the environments folder, you need to have a dedicated folder per environment. For example, let's use this one, web app, as an example. And here, as you can see, there are some files, there are some mandatory files that you need to put here. So everyone start actually with this metadata. So you need to put the metadata file here, and then the Azure deploy JSON file. And this file, it basically describes in JSON format. And to be more specific, this is the ARM template. This is the Azure Resource Manager template that describes what you have in your environment. In our case, we will be creating the first type of the resource is Microsoft.web/server farm. And then on top of that server farm, we will create Microsoft.web sites. Why I'm actually showing you this one? Because as a QA engineer, I'm not sure that you really will be working on the infrastructure, but I also assume that on your team, there should be at least one person, or yeah, maybe not a person, but at least a role, and that role can be occupied by a developer, an IT pro, or architect, or whoever else. But still, that role needs to be in each and every project that works with the cloud. That the role of the cloud engineer. Okay, and that person, the cloud engineer person, or the cloud engineer role, actually will create some automation against the infrastructure provisioning. That's just inevitable. I mean, like, this is one of the first practices that you usually introduce for your cloud project. You usually start to introduce with the introduction of the automation for your infrastructure. The point here is that for that automation, there is a very huge chance that the person will use the IRM templates, because this is actually the way how Microsoft recommends to work with that, because IRM templates, they helps you to define in a declarative way what you will have in your environment. And if you have the cloud engineer on the project, and if the cloud engineer already created all that automation in IRM format, you can easily reuse that automation for your Azure DevTest Lab. You don't need to go to the cloud engineer and ask each and every time, hey, please create a new environment for me, please deploy a new application version to that environment, and so on and so forth. You can just get read-only credentials from that repo. You can connect that repo to your Azure DevTest Lab, and from your Azure DevTest Lab, now you, as a test engineer, the test lead, perhaps you can control basically how many environments of that particular topology, of that particular configuration you want to create. I mean, like, how awesome is that? So yeah, that's about the environments. And now let's go and check what we have for the artifacts. So what we've seen during the demo, we've seen that the artifacts folder is not the artifacts folder, the artifacts gallery. The artifacts gallery is definitely consists of much more artifacts rather than environments, and you can actually see all of them here. So you can see a bunch of artifacts for Linux VM, because they start with Linux, and then a bunch of artifacts for Windows VMs. And technically what you can do, again, you can follow the same structure. You can follow the same structure in your private repo. This is also very important. For some reason, I forget to say that when I was talking about the environments, is that you can do all that stuff in your private repo. That basically means that you don't need to expose that to the GitHub publicly. Because when you are connecting, let me show it to you, when you're connecting your repo to Azure DevTest Lab, you provide a meaningful name, you provide the URL, the branch, and again, the access token for that repo. So that can be totally a private repo for you. And yeah, let me just get back here. So for example, let's check what we have here. So under the artifacts, we do have and under the artifacts folder, we do have a dedicated folders for each and every artifact. And let's check what we have here for the VS Code. For example, again, we have some mandatory structures, some mandatory conventions that we need to follow. First of all, the artifact file.json. This file, it basically describes the metadata, the same metadata as I was showing to you for the environments, describing the same metadata for the artifacts. For example, the meaningful title, the name of the publisher, some descriptions, some tags, and target operational system type. This is very important. You can put Windows or Linux here, and that will help the Azure DevTest Lab to understand to which exactly environment that artifact can be applied. And then you provide the run command here. And under the run command, what you are basically doing here, we're doing PowerShell, we're setting the execution policy to bypass, and then we are running install VS Code PS1 script, which is located in this folder. And this one is, as you can see, this is basically more or less the same average PowerShell script. And with this PowerShell script, you can do whatever you want. So that basically means that here in your metadata in artifact.json file, you define an entry point for that artifact, and then that entry point can actually point to the exact, I don't know, like PowerShell script, Bash script, or whatever else that may be. I don't know, like Python script if you'd like. It doesn't matter. You define an entry point, and then you basically pass the control to your custom script, and with your custom script, you can do whatever you want. So that's basically it. Let's check. Okay, yeah. So the virtual machine here was created. So let me actually go here. Let me go with the connect. And let me open this RDP file. Now I need to provide my credentials here. I do believe that that was the password. Yeah, for the first time, it may take a bit longer to connect to the VM. Yeah, but as you can see, I'm more or less successfully connected. Let's just give it a minute. I just want to show you that those artifacts like 7-zip and VS Code, that they were successfully installed on this particular VM. The first time, as you can see, of course, it also takes a bit longer because it needs to set up my user profile, but it will happen only once, only for the first login. But yeah, Visual Studio Code, Google Chrome, as you can see, we have those right here on the desktop. And I also do believe that if I will go here and if I will try to look for something like 7-zip, yes, 7-zip file manager. So all the artifacts that I've asked for the Azure DevTest Lab to be installed, all of them are installed here and they are running perfectly. Okay, I will remove that virtual machine later, but yeah, that was basically it. That's what I wanted you to show for the Azure DevTest Lab. And oh yeah, you know what? Before we will proceed further, what I also want to show you here is that you can also create formulas. There are a few ways how you can do that. For example, if you already have your machine installed here, you can just grab this virtual machine as a formula, or you can go to configuration here, and then yeah, and then you have formulas here, and you can basically add a new formula from here. So what it actually means to create a formula. So let's use Windows 2016. So the formula is a combination of the base image and predefined artifacts. So that basically means if for different scenarios, I may need to have, I don't know, let's say the same base image and the same set of artifacts. And if I don't want to click over and over again, basically to configure the same configuration, I can just say, hey, I have a formula. The name of the formula will be something like test VM, and that test VM will have a set of predefined artifacts from here. Oh, there is actually a Firefox browser. Sorry. Yeah. Anyway, so yeah, let's just grab some URLs here. Just grab some artifacts here, just to use them as an example. But this is basically how you configure your formulas. So the base image is Windows Server 2016 in my example. The few artifacts here. Also, I can provide the default username if I want and the default password if I want. But I can create this formula now. And after that, I will be able to use that formula to create a new virtual machines. Yep. So yeah, now that's definitely it. And I can also see that I'm running out of time. So let me actually proceed with my demos a bit further. So for the links, actually, I was showing you this repo, and here is the link for this repo. The presentation will be available, so you can actually get that from the presentation itself. The next demo, what I was talking about last time, that's the service called Azure DevOps. And for the first demo for Azure DevOps, I would like to show you the demo generator, the tasks and bugs, and also the test cases, the test plans, and so on and so forth. So let's proceed with that demo. Where is it? I do believe that's this one. Yes. So first of all, Azure DevOps Demo Generator. This is the very powerful tool. Again, all the links will be provided after the presentation, but this is actually how the tool looks like, or you can easily Google Azure DevOps Demo Generator. Let me just make it a bit bigger for you. So what you actually can do with this one, you can sign in. You need to sign in basically with the same credentials as you were using to create your Azure DevOps account. And again, I will remind you from a previous session that for Azure DevOps, you can create the account for free. And as long as you have 5 or less users in your organization, that account will remain free forever. Or at least that's what Microsoft says right now, that that account will remain free. So that basically means that you can go to Azure DevOps website, you can create your first test organization there, and then you can go to Azure DevOps Demo Generator. You can select an organization from this list. I will go with Boyko Ant demo organization for obvious reasons. And what you can do afterwards, you can head on this choose template. And as you can see, there are a bunch of different templates that you can use. So those are the predefined templates with tasks, with some source code, with some test plans, and so on and so forth, that you can populate to your Azure DevOps instance. And that will be, believe me, much easier for you to start working with that, especially if you are kind of let's say, not really familiar with the interface and the features and the capabilities. So what I was using for my next demo, I was using the template which called Smart Hotel 360. So I already roll out that Smart Hotel 360 to this DevOps organization, and let's start with the boards. Okay, so if I will go to boards, I do have a lot of the work items here, but let me go to the sprints first. So what I would like to show you here on sprints. So here on the left side, those basically blue guys, they called the product backlog items, and the yellow guys here, this is the engineering tasks that needs to be implemented to close each and every particular backlog item. And additionally, if I will scroll down, you can see that here there is a bug. And the bug, there are a few ways how you can treat those, but what I will recommend you basically to do here, I will recommend to treat bugs in the same way as your product backlog item, because then you may create a tasks, you may create kind of a subtasks for your bug, and at least you will need to create 2 subtasks. I mean, like, that's my opinion, of course, but this is one of the examples. So you can do something like implement fix, that will be your first task, and then retest. Okay, so now you know that to finish, to close basically this one bug, you need to implement some fix for that, and this can be assigned to one of the members of the dev team, and then you need to retest basically that bug and validate that that fix basically fixed everything, and this task can be assigned to a member of your QA team. And let's say that we need I don't know, like 5 hours to implement fix, and then 1 hour to validate that actually everything was fixed. So here, as you can see, in total you will have 6 hours to finish this, to close this bug. Additionally, let's go to test plans. Again, I will show it to you really quick. So what you can do here, you can here basically manage your test plans. So this is the iteration 2, the current iteration. And for this current iteration, as you can see, we have a bunch of different test suites that needs to be tested against this particular release, and for each and every test suite you may have a list of test points. For example, like as a room guest, I should be able to communicate with all smart devices from the app. Let me, you know what, let me probably make this one a bit bigger, and then the set of test points, as you can see here, verify that a notification is auto-closed after X seconds, and so on and so forth. So this is basically pretty much the same interface that you can find in any other tool that you're using to manage your test suites. And I do believe that in this series, we already had a speaker who basically talked about that in a lot of details. So that is why, at least for now, I will skip this part. And what I want to do actually here, I want to do to my next demo. And I would like to talk a bit about how you can do the automation, how you can control the automation flow for your Azure DevOps in terms of the pipelines, and how you can utilize probably one of my favorite features, if not the top favorite feature of Azure DevOps, which called quality gateways. And we will talk about manual approval, we will talk about simple check and long running check here. So before we will proceed with that part, let me just, this is the screen that I was looking for. Let me just say one thing upfront. So at some point, within the Azure DevOps, they decided to split your deployment pipelines into 2 different, let's say, modes. The first one, they call them the release pipelines, the classic version of release pipelines, which actually means the legacy version. And also they do have a YAML pipelines, or just the pipelines, which will basically mean the a bit more modern version of it. So if you will go to pipelines, you will see that I have the releases here. And if you will see a UI like this, if you will go to releases, then you're basically using the legacy implementation of it. It works more or less the same as the new one, but I just wanted to highlight that if you will go to releases area here, then you will be working with the legacy UI, and if you will go to the pipelines here, then you will be working with the new and modern UI. So yeah, please pay attention to that. The functionality is more or less the similar, but you need to use the different approaches how you can configure that. So let's use the first pipeline that I have here, the dev prod dr. Let me run this pipeline. This is basically a dummy pipeline, but what I want to show you here, that as you can see, this is my deployment diagram. So I will first deploy to my dev environment, and then if everything is okay, I will be deploying in parallel to my production and to my disaster recovery environment. So now we need to actually wait a bit because I queued that deployment to my dev environment, but it will actually not be running right away. And why? Because I configured what called the quality gateway for all of those environments. So let me just go here to the environments for now. As you can see, I have dummy dev, dummy dr, and dummy prod. Both of them are configured the same, and they represent only the, let's say, logical environments. Okay, so they don't really kind of tied to specific resources. So let's go to dummy dev, and here I can go to approvals and checks. And as you can see, I have an approval configured here. And as you can see under the approvers, this is basically my name. So that means that I need to provide my explicit approval for each and every release that basically will be deployed to this environment. And how I can do that, let me go to pipelines. I hope that this one is already, yeah, now it's waiting for my approval. As you can see, if I will go here, I see this passage that one approval needs your review. And additionally, if I will go to my mailbox, I will see that there was an email they sent with a notification that I also need to approve this particular release. So I can click on the review, and then I can provide comments, and I can either approve or reject. So let me approve this one. And when I approved it, only after that, the deployment to the dev environment will actually start. So this is the check that is implemented before the environment itself. So as you can see here, one check passed, and now it basically runs just a few dummy scripts in the dev environment, and then it will pass control to prod and dr. Yeah, as you can see, those dummy scripts like configure dev and deploy dev, and then it will pass control to the production and to the dr environment. But what if you need to do something a bit more interesting rather than just doing the manual approval? Here I have environment blue and environment green. And for both of them, I configured two other quality gateways. I implemented them with the Azure functions, but technically they just exposed the HTTP endpoint, and that HTTP endpoint is just called when it's time basically to deploy to this environment. You just get called, and if that endpoint returns HTTP 200, which is okay, then that basically means that the deployment can proceed. If it's not, then that means that the quality gateway failed, and potentially we cannot deploy through this environment. And I'm showing you that I have a simple gate and a complex gate here. So let me explain actually why I have both. So let's say that you have a simple check that may be implemented within one single HTTP request. Let me actually switch to the code, and let me show you some code here. Again, this is the Azure function, but please don't pay a lot of attention to the specifics of Azure function. The important thing that you need to know is that this is the HTTP endpoint. This is just a regular HTTP endpoint that I can call. And here, what I'm doing, I'm just basically putting some information to the log stream. So to the log stream, I write function started, I write everything that I have in my query string. Then I collect all my headers, and I'm basically, again, putting them to the log stream as well. Then I get the request body and put that request body to my log stream as well. And then I'm emulating that for the 3 seconds, we need to do some checks, we need to do some validations, and then I'm basically returning OK object result, which technically means HTTP 200 code. Okay, so this is how you can implement a very, very simple quality gateway for your application. But please be aware that all that stuff, all that action needs to happen within the one HTTP session. And the default timeout, I don't remember exactly, it's either 30 seconds or 60 seconds. But yeah, the bottom line here is that you can use it only for something that is really, really simple. But what if you need to do something that is a bit more complex? Let's say that you have an environment, and let's say that before you will deploy to, I don't know, like before you will deploy to production, you want to run some performance tests, or maybe some, I don't know, like penetration tests or some other tests. You may want to run them against your staging environment, just to make sure that the application that you are deploying gets the same, or let's say the accepted level of performance, the accepted level of security, and so on and so forth. In that case, of course, 60 seconds will not be enough. So you need to implement that in a bit different way. Here I have my other example, and again, that source code that I'm showing to you right now, that code also will be shared with all of you in the presentation. There will be a link how you can get to it. So yeah, don't worry, you will be able to check all that things later. So this is the setup that I'm using basically to run my long running check for my long running complex gateway. This guy here, this is the same HTTP endpoint. So it gets, as you can see, it gets the query, it gets the headers, and it also gets the request body. Then it serialized everything, into the JSON, and then it sends basically that JSON to the queue, to some custom third-party tasks queue. In this case, of course, they are also implemented within the Azure, but that's not the point here. The point here is that as soon as I basically combine everything that I need, I also, just for the demo purposes, basically put the same data into my output log stream. I create a message. This is the cloud queue message. As you can see, I added that message to my queue, and after that, I'm returning the HTTP OK response. So this part of the function that happens really, really fast, it happens maybe like in less than 1 second, because the goal here is just to collect all the parameters, all the attributes, then queue some long running task and return the control back to the caller. And here I have my second piece of code. Here I have my second Azure function, which is triggered when the new message arrive in a queue. And let me just collapse those guys a bit. So what is happening here? So basically, I'm getting this message from the queue, and then, as you can see, I'm emulating some load, and I'm just saying that for the 5 minutes, please do nothing. And yeah, I mean, like, we will treat that as a long running task. After that, what I need to do, I need to run all my checks. I need to understand, is it okay to basically reply that this particular quality gateway passed successfully or not. I just need to create a URL, and that URL, it consists of the plan URL, the project ID of my Azure DevOps, and so on and so forth. But the thing is that you will actually get all those values, you will get all those components that you're needed to construct that URL, you will get it from the original HTTP request. So when the Azure DevOps will call you, it will also send all the required information for you to call it back when the quality gateway actually finished. Then you basically need to create a body. And in my case, as you can see in the body, I'm basically given a message that task was completed and it was completed successfully. It succeeded. Or I can say that it failed. Depends on actually what kind of a scenario I want you to show, or what kind of scenario it actually is for your custom gateway. And after that, what I'm doing, I'm basically serializing everything, and I'm just sending a regular HTTP request with a regular HTTP client. And if I will go back to my Azure DevOps, which is here, what I will do, I will go to blue-green pipeline. And as you can see, I will open the last run because technically we don't have enough time now to run it again. And as you can see here, 2 checks passed. If I will open, the simple gate and the complex gate both passed successfully. The same for the second environment here as well. And I can also, as you can see, yeah, I can also see that everything here was deployed successfully. Again, this is the dummy build, but still I have all the logs in place. So this is actually it. That was that part of the demo that I was about to show you. I know that it was probably a bit fast, but anyway, the thing is that the URL for the Azure DevOps daemon generator and also the URL for my code examples that I showed you today, they are both here, they're both in the presentation, they are both available for you to check, so feel free to do that. And also, please don't forget that I invited you to visit this particular website if you want to know a bit more about Azure in general or Azure DevOps. Please follow this link, aka.ms/learn, or scan the QR code. You will be able to find a lot of different examples and much more deeper documentation there on the website. And at this point, I can see that we already have a message in the chat. On this point, I invite you to ask all the questions about this particular presentation. Okay, so we do have messages in the chat. It was not a question, it was just a sum up. So thanks Vlad for a sum up. I assume that that means that you like the presentation. And this is actually really cool that that you liked it. But anyway, while we're here on the call, guys, as I was saying, I invite you to ask all the questions that you may have about this session or maybe previous session. Yeah, I will be happy to answer them. And while you are thinking on your questions, I will take a sip from my coffee cup. Okay, awesome, nice feedback. So at least I was able to convince one more person to start using Azure DevOps or Azure in general. That's really cool. Thanks, Vlad. Great demo. Yeah, thanks, Sergey. I like that you liked it. Okay, so in that case, assuming that there are no more questions for this session today, I would like to say thank to all of you again. Thanks to all the attendees. Thanks to everyone else who will watch this session in recording. So again, you can see my email here. Feel free to ask all the questions that you may have after this presentation. Feel free to send those questions over the email. As I was saying, I try to reply to all my emails, and I will be happy to discuss with you all your cases that you have around Azure. So again, thanks guys, have the good rest of the day and see you soon on my next sessions. Bye-bye.